I think Shreya missed my last class, right?
Yes, ma'am.
Um,
Ma'am, I also missed your last class, ma'am.
Last class, no, you were attended my last class. Shreya was absent. Last Saturday, I didn't take the class.
Oh, ma'am. Okay.
I think Richa ma'am took my class Saturday. Okay. Uh, in the last class, we were discussing about factorization, right, Panchami?
Yes, ma'am.
Yeah, today we'll discuss about identities. Okay. I think already you know all the things. We'll move on one by one. Okay. A plus B whole square is equal to. Can you tell me the formula?
Ma'am, a square plus 2ab plus b square.
2ab plus b square, right? Okay. For example, if there is 3x plus y whole square, right? See, if you see the problem, so you should know which formula you have to apply. Here we have two terms, right? No, like A and B. Here also we have two terms. So 3x is one term and y is another term. There is plus between the two terms and there is whole square, right? No? So that time we had to use A plus B whole square, right? What is A here? A is equal to 3x and y is b is equal to y. Okay. So you write the formula a square plus 2ab plus b square and now substitute these values in place of a and b, right? So a is equal to 3x. What is there in the formula? A square means how to write 3x in place of
3x whole square, ma'am.
square. You have to use bracket because we have to constant two not two terms, constant and variables, right? No, so 3x whole square plus 2ab means 2 into 3x into y plus b is y square. So what is 3x whole square? Whole square means you should know that 3x. See, sometimes children will write 3x square, right? No, but that is wrong. You should multiply 3x. How many times? 2 times, right? 3 3s are 9. X into x is x square. So it is 9x square plus, so this is one term, right? 2 into 3, 6, 6 into 1, 6, x into y, xy plus y square. Right now, children? So let us go to the another formula. A minus b whole square. A minus b whole square. Same formula, but you have to
A
change.
square minus 2ab plus b square.
Very good, Shreya. Minus 2ab plus b square. Okay, formula is same, but here we are using minus sign. Minus 2ab plus b square. Okay, I'll give one more example. 5a minus 2b whole square. So this is a, this is b. So in place of a, I will write 5a whole square. See, whenever you have two terms or minus sign, don't forget to use brackets. 2 into. Says here, what is b? In place of b, we have 2ab. You should not write minus 2ab. Okay, because in the formula already we have minus sign. So no need to write b is equal to minus 2b. Okay, I will tell you in another next formula. That time you have to write the signs. Okay,
Ma'am,
here,
I got the answer.
very good. Okay, 5a into 2b plus what is b here? 2b whole square. Right now, children? So what is 5a whole square? 5 square is 25, a square, right? 5 twos are 10, 10 twos are 20, a into b is ab plus 2b whole square. 2 square is 4 and b square. This is your answer. And next one, what is a square minus b square? Tell me first, what is a square minus b square?
Ma'am, a plus b bracket and a
Into,
minus
yes, a plus b into, very good, a minus b. This is a square minus, sometimes if they give a plus b into a minus b, that time you have to write a square minus b square. If they give a square minus b square, you have to write a plus b into a minus b, right? For example, x square takes a simple example, x square minus y square. So here, so both are different variables, right? Now x is different, y is different, and we should have squares for both the variables, and there should be minus sign between the two variables, two terms. Okay, that time we have to use this formula. So x plus y, write the two terms x plus y into x minus y. We are the terms are same. We are changing the sign. Okay. Yes. Next, fourth one is, which is fourth formula? X plus a into x plus b. Do you know the formula? What is x plus a into x plus b? Say yes or no. Okay, I will give you x square plus a plus b into x plus ab. Right, children? X square plus a plus b into x plus ab. So this is the formula, and I'll give an example. A plus 5 into a minus 4. Okay. See, here the first terms are same in the formula. First terms, see, x is same here, right? The first terms are same, but second terms are different here. Okay, so here it is a and it is b. If first some terms are same, then you can use this formula. Okay, what is x here? X is equal to a, right now? See the formula and write in place of x, we have a. In place of a, we have 5. And what is b here? Tell me, what is b?
Ma'am,
Minus 4. Here you are writing minus 4, okay, along with the sign. Because in the formula we have plus sign, but here we have a minus 4. Okay, so in place of, this is plus b, right now, children? So in place of b, we have minus 4. So I have written b is equal to minus 4. Now use the formula x square. What is x here? Just substitute the values. A square plus a plus b. See, a plus b. Write in bracket a plus b. B is nothing but minus 4. Or you can write directly minus 4, no problem. Into x. X is a plus ab. A is 5. B is minus 4. See, I'm using bracket here because we have minus sign here. Okay. Did you understand this step, Panchami and Shreya?
yes.
First step, Shreya. Shreya, did you understand the first step?
Yes, ma'am, I understood.
Okay. Now, a square plus, see, 5 plus into minus is minus, right now. So it becomes 5 minus 4. So I will write directly 5 minus 4 is nothing but 1 a. 1 into a is a. So here plus 5 into minus 4, that is 20. So the answer is a square plus a minus 20 is the answer. See, when do we have to use this formula? Means when the first terms are same. See, these are binomials, right? No? When the first terms are same, second terms are different, that time you have to use this formula. Okay. And a plus b whole cube. What is a plus b whole cube? A cube plus b cube plus 3ab into a plus b. Right, children? For example, 2x plus 5y whole cube. So it is a, it is b. See, a cube. In place of a, I am writing 2x. Okay, 2x whole cube. See, if you do if you follow the steps correctly, okay, you will not do any mistakes, children. In place of b, I am writing 5y whole cube plus 3 into, right now 3ab means 3 into a into b. What is a here? 2x, b is 5y, put bracket a plus b, that is 2x plus 5y, right? What is 2x whole cube? Cube means you have to multiply 3 times, right? No, 2x into 2x into 2x. So 2 2s are 4, 4 2s are 8. X into x. What is x into x?
Ma'am, x square.
X square into x is?
X cube.
Very good. So we have to add the powers right now. See, variables are same. When the bases are same, you have to add the powers. That is 1 plus 1 plus 1 is 3. It is 8 x cube plus 5 to the power of 3. 5 5 is 25. 25 5s are 125 y cube plus 3 2s are 6. 6 5s are 30 xy 2x plus 5y. Write as it is. One 125 y cube. See, now we have 30 xy here into 2x plus 5y, right now. So you should multiply both the terms. Whatever you have inside the bracket, 2x plus 5y will be multiplied by 30 xy. First multiply 2x and then 5y. So 30 into 2 is 60. Right, children? What is x, y into x? X into x is x square y plus 30 into 5 is 150 xy into y. See, same y and y, same variable. So I'm multiplying that. Y into y is y square. So this is your answer. See, if there are like terms in the sum, then you can simplify that, whether you can add or subtract. Okay. See, all these are unlike terms. This is x cube, y cube. This is x square y. This is x y square. All the terms are different. So keep as it is. Okay, children. And same thing, a minus b whole cube. Okay. Same formula, a cube minus b cube minus 3ab into a minus b. Okay, I think you know how to do this right now. A like a plus b whole cube. Wherever you have minus sign, you have to put minus sign. Okay, then I explained polynomials, no, last class. Yes, types of polynomials. Okay, we'll go to geometry. Who is father of geometry? Tell me, who is father of geometry? Shreya, Panchami? You have studied in 9th standard.
Yes, ma'am. Euclid.
Yes, Euclid. Okay. Euclid is father of geometry. Okay. So no need to start from point, angle, everything. No, you know everything, right? No need to start from point, no?
Yes, ma'am.
Line segments, everything, you know what is ray, what is line segment. Okay, I don't teach all those things. I will start from just a basic concepts. Linear pair of angles. Linear pair of angles. Okay, where do we get linear pair of angles? See, when a line is, when a ray is standing on the straight line, how many angles are forming here? Two angles, right now. So this is one angle and this is another angle. We have two angles here, right? So these two angles are called linear pair of angles. Okay, and what is the sum of these two angles? You know, this is straight line, right now, children? And what is this angle?
180-degree, ma'am.
Very good. 180 degree. Very good. See, the sum of these two angles should be 180 degree, right now. See, if one angle is 60 degree, what is another angle? What is the measure of another angle? One angle is 60. What is another angle?
120, ma'am.
Very good, 120. Right now, because total should be 180 degree right now. So if one angle is, for example, one angle is, see, this is acute angle, this is obtuse angle, right? If X, it is 100. So what will be the another angle?
80-degree, ma'am.
80 degree, very good. Okay, I think you understood what are a linear pair of angles right now. When a ray is standing on the straight line, okay, the sum of the angles will be 180 degree. And next, vertically opposite angles. Vertically opposite angles means, see, when the two lines when the two lines, this is L and this is M. Okay, line can be denoted by single letter, no problem. Okay, line, straight line, not the line segment. Straight line can be denoted by single letter. Okay, this is line L and this is M. When two lines intersect, meet at a point, see how many angles are forming here? Four angles, right? See, this is 1, 2, 3, and 4. Right, children? There are four angles. So how the four angles are? You know that? See, the name itself is telling right now. Vertically,
Opposite angles are equal.
yes, the name itself is telling vertically opposite angles are equal. So which is opposite to 1? 3. Right, children? So 1 and 3 are equal and 2 and 4 are equal. So angle 1 is equal to angle 3, angle 2 is equal to angle 4. These are vertically opposite angles. Suppose if it is 70 degree, can you tell me remaining angles, children? What is 3 here?
Ma'am, 3 is 70 degree and 2 and 4 are 110 degree.
Very good. How will you get 110 110 degree? See, it is linear pair of angles, 1 plus 2, right now? See, this is linear pair, this is straight line and the line is standing on the straight line. So we are getting two angles here. The sum of these two angles will be 180 degree. If it is 70, it will be 110. So if 2 is 110, 4 is also 110 degree. So like this, we find the angles. Got it? And third one is parallel lines. Parallel lines. Where do you see parallel lines?
Ma'am, railway lines.
Okay, railway track. Okay, so parallel lines. What are parallel lines? See, these two are, this means the line is extending in both the sides, right now. See, these two are parallel lines. Both are extending in both the direction, right now, and the distance between the lines will remain constant. It will not change. And even though if you extend in both the direction, the two lines will not meet each other. Okay. Will the railway track meet each other? No, the lines will not meet each other, right now, children? They will not meet each other, right? So they are called parallel lines, right? So the distance between the lines remain constant. They will not meet each other. Next. See, this is transversal. See here, this is called transversal. Transversal is cutting the parallel lines at 2 points, right? You can call it as X and Y. Okay. Transversal is cutting the parallel lines at 2 points, X and Y. So how many angles are forming here? We'll count. Okay. 1,
8 angles.
8 angles. 2, 3, 4, 5, 6, 7, 8. 8 angles are forming here. So you should know which are all equal. Okay. What are they called? Okay. So, you know, see the two lines are intersecting at point means vertically opposite angles are equal. Already you know the concept. And 1 plus 2 is equal to 180-degree linear pair of angles. So other than that, okay, which angles you will come to know means alternate angles. And before that, see, interior and exterior angles. Interior means what? Inside the two lines. Exterior means outside the lines. So which are interior angles here? So inside the two lines, which angles are here? 3, 4, 5, 6. Right? These are interior angles. Exterior angles are 1, 2, 7, 8. Those are exterior angles. So here, which are alternate angles? Alternate angles means they are in means Z-shape angles are called alternate angles. Okay. See, these two are alternate. Are like this. Okay. So Z-shape angles are alternate angles. Here, which is alternate angle to angle
4,
3.
6.
4, 6, and very good.
3 and 5, ma'am.
3 and 5, very good. So alternate angles are equal here. Okay. Angle 3 is equal to angle 5. Angle 4 is equal to angle 6. Very good. Then which is alternate angle for 1?
Ma'am, 7.
Very good. 1 is equal to 7 and 2 is equal to 8. All these are, so interior alternate angles, exterior alternate angles. Okay, children. So Z-shape angles are called alternate angles. Next one is corresponding angles. Which are corresponding angles here? Okay,
1
tell
and
me.
5, ma'am.
Very good. So, corresponding angles will be the same side of the transversal. Okay, see, this is transversal. You have to see the same side. Okay, see, alternate means opposite side. We are writing 3 and 5 are opposite to each other. 4 and 6 are opposite to each other. But corresponding angles are on the same side of the transversal. So 1 and 5. See, if you see the angle, you can know one is acute angle and another one is obtuse angle here. Right now, children? See, this is acute and 4 is obtuse. 5 is acute, 8 is obtuse. So 1 is acute angle, no? So which is acute angle here? 5. Okay. So 1 is equal to 5 and which is another pair? 4 is
4
equal
is
to
equal to
8.
8.
Very good. 2 is equal to
6.
6. Very good. 3 is equal to 7.
7.
These are called corresponding angles, children. Okay. Did you understand all the concept? If you have any doubt, you can ask me. Okay. So I'm going fast because you know all these concepts very well. Okay. If you have any doubt, you can ask me without hesitation. Okay. Did you understand this? What are alternate and corresponding angles, parallel lines, everything?
Yes, ma'am.
Okay, fine. Thank you.
Yes, ma'am.
Next. Okay, we'll go to the figures, triangle. So you know the difference between plane figures and solid figures, right? Plane figures and solid figure. Can you name the plane figures? Any two plane figures? Plane figures.
Ma'am, quadrilateral.
Quadrilaterals. Okay.
Ma'am, pentagons.
Pentagons. Okay. Then,
Ma'am, hexagon.
okay, polygons. Okay, tell me other types. What about triangle? Triangle is plane figure, right? No. Then square, rectangle, and also circle, right, children? So these are all plane figure. Can you tell me which are solid figures?
Cone.
Cone. Very good. Then,
Ma'am, cylinder.
sorry,
Ma'am, cylinder shape.
cylinder. Very good. Cylinder, cube, cuboid, right? No, and sphere. So these are all solid figure. So what are the difference between plane figures and solid figure? See, they are called 2D shapes, right? No, and these are called 3D shape. What D means what? Dimensions. Okay, they have only 2 dimensions, 2-dimensional figures. So these figures have 3 dimensions. For example, if you take board, blackboard, it is in rectangular shape. Right now, you can measure length and breadth of the board. That is not height of the board. Right now, we say it is the length and breadth of the board. Right now, children. So it has only 2 dimensions. But here, if you take cuboid or you're sitting in the room, no, so you can measure 3 dimensions there. Which are the 3 dimensions? You can measure length of the room, breadth of the room, and also height of the room. Right? So we can measure 3 dimensions. That's why these are called solid figure. So another difference is they do not have volume. Right now, can you fill anything inside the blackboard? Can you fill anything inside the blackboard? And sorry,
No, ma'am.
no, you cannot fill anything inside that. You can write on the board. What is that region is called? What is it called? That is called area, right? No, surface area, right? So here it has volume, children. So you can fill anything in the cone or right now ice cream. You will fill ice cream or what? Churmuri, right now that is cone shape, right? So cylinder. So these solids have volume, but the plane figures do not have volume. Understood? They have surface area. And these solids also have surface area. Okay. Don't confuse that. They have surface area and they have volume. but plane figures do not have volume. So these are the difference between plane figures and solid figures. So now triangle is plane figure, right? So what are the elements of triangle? So there are three vertices, right? Which are the three vertices? A, B, C. And there are three sides. Which are the three sides? AB is one side, AB and BC and AC. These are the three sides and three angles. Three angles. Which are the three angles? Angle A, angle B and angle C. So these are the elements of triangle, right now. So you know already the types of triangle. No need to explain the children because I will explain about congruency. Okay, you have that in 10th standard. And what is the sum of the three angles of triangle?
Ma'am, it's 180 degree.
180 degree, very good. And I'll tell you about the exterior angle. See A, B, C, D. Say BC is produced to D, point D. So here it is called exterior angle. Okay. So exterior angle, how will you write? See, while naming this angle, we are here, there are two angles are forming, right now, children? So this is one angle and this is another angle, right now. You should not write only angle C. You can write angle A here because at the point A, there is only one angle. You can write angle B, but you cannot write angle C. Okay. While naming this, you should write along with the other 2 points, A, C, D. So A, C, D is equal to exterior angle is equal to sum of which two angles? Do you remember?
Ma'am, ACB.
ACB. No.
Um,
Ma'am, it is the sum of A and B.
Very good. It is sum of A and B. Very good. Okay. See, exterior angle is equal to sum of interior opposite angles. See, sum of interior. Which are interior angles here? See, interior means ABC, all are interior angles. What are they saying? Interior opposite angles. Okay. So opposite angles means you have to take A and B. Got it? So ACD is equal to sum of A and B. For example, if it is 110 degree and B is 50 degree, what is angle A here? What is angle A, children?
160 degree.
60 degree. Very good. See, sum of these two should be 110. Right now. So 110 is equal to. So A is A plus B is 50 degree. So 110 minus 50 is equal to 60 degree. So angle A is equal to 60 degree. Got it? So this is exterior angle of the triangle. So and what is the area of triangle? Area is equal to
Ma'am, half into
Half
base.
into B.
half into base into height. Very good. Then I'll teach you about congruency, children. This is very important. You don't have congruency, but you have similar triangles. Okay, similar congruency. What do you mean by congruency? For example, if there are two triangles XYZ and PQR. Okay, there are two triangles. If all the sides and all the angles of one triangle are equal to all the sides and angles of another triangle, okay, corresponding sides and corresponding angles are equal, then the two triangles are said to be congruent triangles. Okay, and here, did you understand? Okay, I'll give you some rules. First one is SAS. What is SAS rule? S is nothing but side. A is nothing but angles. Okay, side, angle, side. Side, angle, side means if two sides and here it is very important, included angle. If two sides, see S and S is nothing but two sides and included angle of one triangle are equal to corresponding. These words are important, children. Included, corresponding, two sides and one angle of another triangle. Okay, so then we say the two angles are said to be congruent. Okay, see here, these two are triangles. For example, X and P are equal. Sorry, we are talking about sides first. Okay, for example, XY is equal to PQ. See, I'm writing here. XY is equal to PQ of another triangle and XZ is equal to PR. See, I'm putting two lines here and here I have used only one line. Okay, XZ is equal to PR. So XY is equal to PQ and XZ is equal to PR. They are corresponding sides. And which is included angle? The angle is forming between these two sides, right now. So then only we say they are congruent. Okay, two sides and included angle. So what we have to write? Angle X is equal to angle P. So this is side. So this is also side and this is angle. See, SAS according to, see, we have proved any three elements are equal in the triangle. Okay, in that first we are going to prove two sides and one angle. If two sides and one angle of one triangle are equal to another triangle, then you can say, see, no need to measure all the sides and all the angles. Understood? See, there are three sides and three angles. No need to measure all the six. Okay. By measuring only three, we can say whether they are equal or not. Got my point? Shreya, Panchami?
Yes, ma'am.
Are you understanding? So no need to measure all the six elements. So by measuring three elements, we can say whether they are equal or not. So here we have proved two sides and included angle are equal. So we can say that triangle XYZ is congruent. So this is the symbol of congruent. For similar, we use only this. Okay. So if you know this concept, you will understand triangle chapter very easily, children. PQR. So both are congruent. This is what? SAS. And the second one is ASA. What is ASA? two angles on one side. Okay. Two angles. For example, take ABC and PQR. Here angle B is equal to angle Q. Angle B is equal to angle Q and angle R is equal to C. C is equal to angle R, then BC is equal to QR. Okay, so two angles, angle, angle and side. If two angles, see, if two angles on one side of triangle are equal, then we can say triangle ABC is congruent to triangle PQR. Okay, children. See, are you getting any idea? For example, if it is 60, see the line will goes like this only, will go like this, right? No, if it is 70 degree, it goes like this only, right? No, so then these two should be equal. If two side angles are equal, they will meet at the same with same length, right? No, so then the line will the bases are same and the two angles are equal. So then we can then remaining all will be equal. A is equal to P, AB is equal to PQ and AC is equal to PR. So remaining all will be equal. If two angles, see two angles and one side of one triangle are equal to corresponding angles inside equal, then we say the two triangles are said to be congruent. This is ASA rule. Next one is, see there is SSS also. Okay, SSS means all the sides of one triangle are equal to all the sides of another triangle. It is very easy, right? No, so all the sides are equal. Okay, corresponding sides are equal. If it is 5, 5, 6, 6, 7, 7 like this. Okay, if all the sides are equal, then it is SSS rule. And there is one more rule, RHS congruence rule. See, R is nothing but what? You know what is RHS? Which rule is it?
Ma'am, right angle, hypotenuse and side.
Side. Very good. Right angle, I will write 90 degree. This is hypotenuse and the side. For example, take a right angle triangle. See here, this is right angle and this is also right angle. So right angle means both will be equal. Then hypotenuse are equal. Hypotenuse are equal. Then any one side, the remaining, we have two sides here. So either take this or this, no problem. Take any one of the sides, okay? So hypotenuse should be equal, right angle should be equal, any one of the sides should be equal. Then we say the two triangles are congruent. This is RHS. Got it? And come to quadrilateral, children. What do you mean by quad?
Four-sided.
Yes, four-sided figures are called quadrilaterals. Okay, so we'll start with square.
Ma'am, I'm not able to view your share screen. So, ma'am, can you present it again?
What about Shreya? Can you see the board?
Yes, ma'am, I can see.
Yes. Once you log out and log in, Panchami. So what is square? What are the properties of square, Shreya? All the sides are equal, right now. Sides are equal. And what is the angle of each? What is each angle here?
90 degree, ma'am.
Each angle is 90 degree. 1 second. Can you see now, Panchami?
Yes, ma'am. Now it's visible.
Okay, good. So square means all the sides are equal. Each degree is 90 degree. What is the sum of all the angles of quadrilateral?
360 degree, ma'am.
360 degree. And what is the area? Area is equal to, all the sides are equal, right? So what is area of square? That is A into A square. What is perimeter of the square? What is perimeter? Perimeter is nothing but boundary, the length of all the sides, right? No. What is length of all the sides here? See, A plus A plus A plus A, right? No. Say if it is 5, all the sides are equal, 5. It will be 5. What is the total length means? What will you say? 5 plus 5 is 10. 10 plus 10 is 20. So it is sum of all the sides. So it is A plus A plus A means that is 4A. That is perimeter of the square. And next, rectangle. So rectangle means fours. All these are special type of quadrilaterals, right? No, because they have some special features. Okay, based on some features, special features, they are classified. Means we have given some names, right? No, square, rectangle, rhombus, parallelogram, trapezium, kite. These are special feature quadrilaterals. Okay, so here which sides are equal?
Opposite sides are equal.
Opposite sides are equal. So here also each angle will be 90 degree. And what is area? Area is equal to, this is length, breadth, length, breadth. What is area? See, in square we took A into A, no? A into A is A square. That is area of square. So what do we have to take here? Take length and breadth. L into B. That's it. Here we are taking A into A. Here it is L into B. That's it. Okay. So L into B. What is perimeter?
Ma'am, 2L plus B.
L plus L is 2L. B plus B is 2B. So 2 is common in both. I will take it outside the bracket. So 2 is out. What is remaining here? L plus B. Okay. This is perimeter of rectangle. And third one is parallelogram. Which sides are equal in parallelogram?
Ma'am, opposite sides.
Yes, like rectangle. Opposite sides are equal. Which angles are equal? Which angles are equal here? Same, opposite angles are equal. Opposite sides are equal. Okay. Opposite sides are equal and opposite angles are equal. Then what is the sum of adjacent angles in parallelogram?
Ma'am, I think 180.
Very good. Yes. For example, adjacent angles means what? Having same, for example, A and B. A and B are called adjacent angles. A and D are adjacent angles. B, C or D and C. These are adjacent angles. See, the two angles are having same side, right now. See, DC is common for D and C, like that. Okay, A plus B is equal to 180 degree. So sum of two adjacent angles will be 180. So if you know one angle, you can find remaining all the angles. If it is 70 degree, what is D here? What is angle D?
Ma'am, 70 degree.
70 degree. So what is C? R A? Just now I told you, no, the sum of the adjacent angles will be 180. Right now, 180. Say, you can take C plus D is equal to 180, or you can take A plus D is equal to 180. So C,
Ma'am, it is 110.
yes, 110. What did Panchami say? Sorry, I didn't hear.
Ma'am, 110 only.
110. Yes. C, the angle C is equal to 180 minus 70. It is 110. Okay. So 110 and C is also 110. Okay, children. And what is the area of parallelogram? Area of parallelogram is base into height. That's it. Okay. For triangle, it is half into base into height. For parallelogram, it is only base into height. Then rhombus. Sorry. Yes. Which sides are equal in rhombus?
Ma'am, actually all
Like,
sides are equal.
yes, yes, all sides are equal. All sides are equal. Then opposite sides are parallel to each other. Okay, these two are parallel and these two are parallel to each other. And which angles are equal here? Which angles are equal? Or all the angles are equal? No. Opposite angles are equal. Okay. Opposite angles are equal. And you know the diagonals bisect at bisect perpendicularly. Right now, bisect at 90 degree. You should know this, children. Okay. Diagonals are bisecting at 90 at right angle. Okay. So these are the properties of rhombus. And what is the area of rhombus? That is half into D1 plus D2. D1 plus D2 are the diagonals of the rhombus. Okay. Then trapezium. So what are the properties of trapezium? So it has one pair of parallel lines. Okay, see these two are parallel, but these two are not parallel. Okay, so it has only one pair of parallel lines. Okay, so and what is the area of trapezium is? It is half into height into, for example, if it is PQRS. See what is the area means? See this is height right now. So this is base right now. See base means here we have to take the sum of the parallel lines. Okay, that means PQ plus SR, or we write A plus B like this. A plus B is nothing but the length of PQ and SR. You got it? So it is half into height into sum of the parallel lines. Got it?
Yes, ma'am.
Huh. Shreya, got it?
Yes, ma'am.
Okay. And last one more, midpoint theorem. What is midpoint theorem? For example, it is there in your triangle chapter, children. See, ABC is a triangle, and I am taking midpoints of AB and AC. Okay, E and F. Okay, so E is midpoint of AB, F is midpoint of AC. Okay, E is midpoint of AB, F is midpoint of AC. So now I will join these 2 points, E and F. Okay, now it is, see what the midpoint theorem says, EF is parallel to BC. Okay, so when we join the midpoints of 2 sides of a triangle, so that will be parallel to the third side of the triangle. Say it is parallel to third side, and it is half of the base. Got it? EF is half of the base. It is parallel and half of the base. This is what midpoint theorem, children. Okay, based on this, you will have sums in triangle chapter. Did you understand this? See, nothing, just we have taken midpoints of 2 sides, and it is parallel to third side and half of the third side. That's it. Okay. This is about midpoint theorem. We'll continue in the next class, children. Okay. Okay, I think both of you got all my points, right?
Yes, ma'am.
No doubt. Okay. Thank you, children. We'll meet in the next class. Okay.
Thank you, ma'am.